You open your eyes. You are falling. Not the sudden falling of a dream, not the jolt and the gasp and the waking up. A slow falling, a steady, deliberate descent through something that is not quite air and not quite anything else you have a name for. Above you, the sky. But the sky here is not blue. It is not pink or orange or the black of space. The sky of Jupiter is cream and brown and amber, layered in bands that run from horizon to horizon in great parallel rivers, each one a different shade, each one moving at a different speed in a different direction. It is the most beautiful sky you have ever seen. Below you, more sky. There is no ground. You look down and you see the same bands continuing downward, the layers of Jupiter's atmosphere, extending beneath you as far as you can see and farther than you can see. A deeper and deeper and deeper into the planet with no floor, no bottom, no surface waiting for you somewhere below. You are falling into Jupiter. You are going to keep falling. And the further down you go, the less the word falling is going to mean what it means right now. Jupiter has no surface. This is the fact that defines everything about this story. Every other planet in this series had something beneath you, a floor, a place where the falling stopped. Mercury had ancient rock. Venus had hardened lava. Mars had red dust. There was always ground. Jupiter has no ground. Jupiter is made almost entirely of hydrogen and helium. In its upper layers, these gases behave as gases. As you go deeper, the pressure increases and they behave as liquids. As you go deeper still, the hydrogen becomes something that has no real equivalent on Earth, a state of matter where it conducts electricity like a metal while still flowing like a liquid. And at the very center, there may be a solid core, dense and hot and buried beneath tens of thousands of kilometers of crushing pressure. You will not reach the center, but you will not need to. Jupiter will finish what it is doing to you long before you get there. The planet is enormous. Over 1,300 Earths could fit inside it. It is so massive that its gravity influences every other planet in the solar system. It has caught and held more than 90 moons. It has a storm in its southern hemisphere that has been spinning continuously for at least 350 years, a storm larger than the entire Earth. You are falling into this. You are falling into the largest planet in the solar system, layer by layer, and each layer is going to tell you something about what Jupiter is. In this story, you are in Jupiter's atmosphere. You are falling. There is no parachute. There is no way up. There is only down, and what down becomes as you go deeper. The cold is the first thing, and you are high in Jupiter's atmosphere, in the upper cloud layers, and the temperature here is around -145 degrees Celsius. This is cold in the way that deep space is cold. Not the biting cold of a winter day, not the dry cold of a mountain peak. A fundamental cold. The cold of a place far from the sun, where the atmosphere has not yet had the benefit of the deep heat rising from below. But the cold is not what you notice most. You notice the wind. The winds of Jupiter are among the fastest sustained winds in the solar system. In the jet streams between the cloud bands, the wind moves at over 500 kilometers per hour. You are inside one of these winds right now. It is not carrying you upward or downward. It is carrying you sideways, the horizontal motion of Jupiter's atmosphere enormous and relentless. Pulling you along the band, you have entered the way. A river carries something dropped into it. You spread your arms. The wind takes them. The sensation of moving at 500 kilometers per hour through a dense, cold atmosphere is not what you expected. You expected violence. You expected to be battered, thrown around, unable to orient yourself. But the wind is consistent. It is not a gust. It is a river. It has direction and intention, and it simply carries you, the way very fast water carries you if you stop fighting it and let it. You look around. The cloud bands above you are extraordinary. Each band is a weather system, thousands of kilometers wide. The lighter bands are where material rises from deeper in the atmosphere, carrying heat upward. The darker bands are where material sinks back down. And the two types of band exist side by side across the entire planet, moving in opposite directions. The boundaries between them turbulent and detailed, full of eddies and spirals and smaller storms spinning off the main flow. You are very small in this. You are a particle in Jupiter's weather. You look up through the cloud layers above you. The sun is up there somewhere. Jupiter is 5 times further from the sun than Earth is, and the sunlight here is 25 times weaker than it is on Earth. There is light. It filters down through the upper clouds with the quality of light in a very overcast room, diffuse and sourceless. It is enough to see by. It is enough to watch the clouds move. It is enough to understand that above you, somewhere, is the rest of the solar system, and you are falling away from it. You fall through the first cloud layer. The clouds of Jupiter are not water clouds. The uppermost clouds are made of ammonia ice crystals, the same compound found in cleaning products, frozen into tiny white particles that form the pale bands of the upper atmosphere. You pass through them, and they are cold and they smell faintly of something sharp that does not have a name, the specific scent of ammonia at extreme cold. Below the ammonia clouds, the next layer. These clouds are made of ammonium hydrosulfide. When ammonia and hydrogen sulfide combine in the right conditions, they form this compound, and its color is what gives the darker bands of Jupiter their brown and orange and reddish tones. You fall through them, and the color changes around you. The pale white of the upper layer gives way to a deeper amber, and a rich orange-brown that is the color you see in photographs of Jupiter taken from space. The temperature is rising, slowly, very slowly, but rising. The upper atmosphere was brutally cold. Each kilometer you descend, the atmosphere thickens slightly, holds a little more of the heat rising from the planet's interior. Jupiter generates its own heat. Unlike the rocky planets, which are mostly warmed by the sun, Jupiter radiates more energy than it receives. Deep inside it, the compression of all that mass produces heat, and that heat rises through the atmosphere and warms the layers from below. You are moving toward that heat. Below the ammonia and the ammonium layers, scientists believe there is a third cloud layer made of water. Water clouds like the clouds on Earth, in the middle depths of Jupiter's atmosphere, and in the right range of temperature and pressure. Water condenses and forms clouds and falls as rain and evaporates and rises again. The same water cycle that drives Earth's weather, running in the darkness thousands of kilometers below the visible surface. You fall toward the water clouds. The light is dimmer now. The upper layers are above you, filtering what little sunlight Jupiter receives, and down here in the middle atmosphere, the light has the quality of deep twilight. Not dark, not black, a deep amber twilight, the colors of the clouds around you visible but muted, the details softening. A bolt of lightning crosses the cloud layer to your left, not the thin, jagged lightning of an Earth thunderstorm. Jupiter's lightning is thousands of times more powerful. The bolt is thick and branches widely and lasts longer than lightning should, and the discharge illuminating the clouds around it with a blue-white flash that turns the amber atmosphere briefly pale. You feel the thunder, or not thunder. There is no sound in the usual sense, but a pressure wave, a physical pulse moving through the dense atmosphere that you feel in your chest before you hear anything. Jupiter's interior is making its presence known. You drift sideways. The wind has carried you far from where you started. You do not know how far. There is no landmark to navigate by, no fixed point in this world of moving clouds. You have been moving with the wind for hours, carried along a band, and now the band curves and you curve with it, and you see it. Far below you, and to the south, the Great Red Spot. From space, the Great Red Spot is a reddish oval in Jupiter's southern hemisphere, roughly the size of Earth. Yet from here, from inside the atmosphere above it, It is something else entirely. It is a storm. A storm that has been spinning without stopping since before America existed, since before the Industrial Revolution, since before most of the cities on Earth were built. 350 years of continuous rotation. The winds at its outer edge move at 450 kilometers per hour. From above, it looks like an eye, the shape of it, the way the clouds spiral into the center, and the way the center is slightly different in color from the edges. A deeper red, as if whatever process makes the spot red is most concentrated there. An eye looking upward from the depths of Jupiter, an eye that is older than anything alive on Earth and larger than the entire planet you came from. You watch it from above. The storm is not moving the way you would expect a storm to move. It is not rushing or violent at this scale. From here, it is slow, majestic, the whole structure rotating with the patient certainty of something that has been doing this for centuries and sees no reason to stop. You are falling toward it. The bands you have been traveling along curve around the outer edge of the spot. Some of what flows along the bands gets drawn into the storm. Some gets pushed around the outside. You watch the flow, and you understand, slowly, that you are being carried toward the edge of the great red spot. There is nothing to hold on to. There is nothing to hold on to anywhere in Jupiter. The great red spot is shrinking. Scientists have been watching it for 2 centuries, and it is smaller now than it was when they first measured it. Yet in the 1800s, it was wide enough for 4 Earths to fit across it side by side. Now, only 1 Earth would fit. It is still the largest storm in the solar system. It is still 350 years old, but it is shrinking, and no one knows if it will eventually disappear or if it will stabilize at some smaller size and keep spinning for centuries more. You are falling toward a storm that may be dying. That is not a comfort. The outer edge of the great red spot reaches you before you reach it. You feel it first as a change in the wind. The steady river flow of the jet stream you have been in breaks apart. The wind becomes less predictable, less consistent. It comes from different directions in quick succession. The atmosphere around the storm's edge, turbulent and complex. The meeting point of the main flow, and the storm's rotation producing the specific chaos of 2 large systems in conflict. You are thrown sideways, then down, then sideways again. The gentleness of the upper atmosphere is gone. Down here, near the edge of the storm, the air is doing several things at once. It rises in some places and falls in others. It spins, it shears. The clouds around you are not smooth bands anymore, but tangled, folded things. But the organized structure of the upper layer is broken apart by the storm's interference. The pressure is noticeably different. You can feel it, not on your skin in the way that you feel wind on your skin, in your body. The pressure of Jupiter's atmosphere at this depth is already greater than the pressure at the surface of Earth. Your body was built to function at 1 atmosphere of pressure. You are already well past 1 atmosphere. Your ears tell on you, your sinuses tell on you. The deep ache of a pressure your bones were not made for. You fall faster now. The storm pulls things inward and downward. The rotation creates a low pressure at the center that draws air and everything in the air toward it. You are in that drawing. You are being taken toward the center of a storm that has been spinning for 350 years. You stop fighting it, not from surrender, from physics. There is nothing to fight against, no surface to push off from, no edge to grab. You are inside a fluid, and the fluid is moving, and you are moving with it. You fall. The lightning is constant now, not the single dramatic bolt from before. Constant flickers and flashes in the clouds all around you, the electrical activity of the storm generating discharges every few seconds. The light of it fills the atmosphere with a strobing blue-white that turns the amber clouds pale, and then amber, and then pale again. You cannot hear it. Or you can hear something, a deep, continuous rumble that is less sound than pressure, the storm making itself felt in the air itself. Jupiter is loud in the way that enormous things are loud, not in frequency, in mass. The light is nearly gone. You are deep now. Deep enough that the upper cloud layers are far above you, and the sunlight that filtered down through them in dimming amber is now only the faintest suggestion of light rather than actual illumination. The world around you is dark, not the pure black of space. A deep active dark lit intermittently by lightning, the clouds around you visible only in the flashes. The pressure is serious now, 10 times the pressure at Earth's surface. Then 20. You are past the depth where scuba divers operate. You are past the depth that any unprotected human body was built to withstand. The pressure is not pressing from one direction. It is pressing from everywhere at once. The weight of kilometers of atmosphere above you, transmitted through the dense gas around you in all directions simultaneously. Your ears stopped hurting some time ago. But when pain stops in extreme circumstances, it is not because the situation has improved. It is because the system reporting the pain has been overwhelmed. Your ears have been dealing with more pressure than they can process, and they have stopped sending the complaint upward. Other systems are doing the same thing. Your body has been receiving information about its own damage for some time and is beginning to prioritize. You breathe. The air at this depth is thick, not liquid, not yet, but noticeably denser than the air above. Each breath is harder to draw in and harder to push out. Your lungs are working against the pressure on every exhale. This is the feeling of being deep underwater, but deeper than any diver has ever been, in an atmosphere rather than an ocean. On a planet where the ocean has no floor, the temperature is warmer, significantly warmer than the upper layers. The heat rising from Jupiter's interior has been building as you descend, and down here, it is past uncomfortable, and into a warmth that your body recognizes as different from the cold of the upper atmosphere. Not the heat of Venus, not the direct assault of a planet that bakes everything on its surface. A deep warmth, the warmth of compression, the warmth of a planet that generates its own energy through the weight of itself. You cannot see the moons from here. High above you, above all the cloud layers, above the cold upper atmosphere, Jupiter's moons are moving in their orbits. Io, the volcanic one, the most geologically active body in the solar system, with volcanoes that shoot sulfur hundreds of kilometers into space. Europa, covered in ice. With a saltwater ocean beneath the ice that may be larger than all of Earth's oceans combined. Ganymede and Callisto, cratered and ancient and cold. They are up there. You pass them on the way in, or near them. They are tiny bright points moving against the stars. From down here you cannot see them. From down here there is nothing above you except more Jupiter. It is raining. Not water. Not the water that you hoped for in the middle cloud layers. That water, if it exists where the scientists think it exists, is far above you now. What is falling here is something else. Helium. Deep in Jupiter's atmosphere, helium condenses out of the gas mix the way water condenses to form rain on Earth. Droplets of liquid helium form and fall downward, sinking through the hydrogen below them. Because helium is denser, the droplets fall for thousands of kilometers before the pressure and temperature at the deeper levels dissolve them back into gas, and they rise again, and the cycle continues. Jupiter rains helium. The rain falls through you rather than on you, each droplet of liquid helium passing through the space you occupy with a chill you can almost feel through the chaos of everything else. Some models suggest something else falls here too. Diamonds. Deep in the atmospheres of Jupiter and Saturn, carbon under extreme pressure can form diamonds. The carbon comes from methane in the atmosphere. Under the right conditions of pressure and temperature, the methane breaks apart and the carbon atoms bond into diamond crystals, which fall downward through the atmosphere. Millimeter-sized diamonds, falling through the darkness of a gas giant, eventually reaching depths where the pressure and heat dissolve them back into liquid carbon. It may be raining diamonds around you right now. You cannot see them in the dark, but they may be there. Diamonds and helium falling through the crushing dark interior of the largest planet in the solar system. A rain that no one has seen and that you are experiencing in the last hours of being in a state to experience anything. You fall with the rain. Downward, always downward. Time is strange here. You have been falling for a long time, but time at this depth, under this pressure, with this darkness, does not move the way it moved in the upper atmosphere, where you could watch the cloud bands roll past and measure distance by what you saw. Here, there is nothing to measure by. The darkness is consistent. The pressure increases consistently but slowly. The temperature rises consistently but slowly. You are in the middle of something enormous, and the enormousness of it has swallowed the ordinary markers of how much time has passed. The atmosphere changes. It is not a sudden change. Jupiter does not have a sharp boundary between its gaseous outer layers and what lies beneath. Instead, there is a gradual transition, a deepening and a thickening and a change in how the material around you behaves. The gas that you have been falling through has been getting denser with every kilometer. Now, it is dense enough that the word gas no longer captures it accurately. You are in something between gas and liquid. The hydrogen around you is under so much pressure that it is no longer behaving the way hydrogen behaves at the surface of a planet. It has been compressed, past the point where the molecules have meaningful space between them. It flows. It has the property of fluids without being fully what you would call a liquid. It is hydrogen doing something that hydrogen on Earth does not do. Because on Earth there is no mechanism to produce this much pressure. Moving through it is different. The resistance is greater. You are not falling through thin gas anymore. You are falling through something with more body to it, something that pushes back with more force when you push against it. Your descent is slowing. Not because the gravity is weakened. Jupiter's gravity is 2.5 times stronger than Earth's. And at this depth, you weigh 2.5 times what you weigh at home. Your descent slows because the material around you has thickened enough to provide resistance. The pressure on your body is very large. Numbers become difficult here. The pressure at this depth is hundreds of times the surface pressure of Earth. These numbers do not translate into experience. And the body does not have a way to feel hundreds of atmospheres of pressure as a number. It feels it as compression, as the specific experience of being pressed from all sides simultaneously with forces that your body was not built to resist. But you are still here. Still falling, still aware, for now. A probe was sent into Jupiter in 1995. The Galileo probe. It entered the atmosphere and fell for 58 minutes before the pressure and heat destroyed it. In that time, it sent back data about wind speeds and temperature and pressure and the composition of the atmosphere. 58 minutes. It went about 200 kilometers deep before it was crushed. You have been falling longer than that. You have been falling deeper than that. The probe was built for this. You were not. There is no light here. This is not the amber twilight of the middle atmosphere, not the strobing blue-white of the lightning zones. This is the deep interior dark of a planet, the dark of a place so far below any surface that the concept of surface no longer applies. The dark here is total. But you can feel Jupiter. You can feel it the way you can feel the engine of a large ship through the hull. A deep vibration, a fundamental resonance. Jupiter is not still. Jupiter is never still. The interior of the planet is in constant motion, the hydrogen flowing and convecting, the heat rising, the magnetic field it generates pulsing outward through the planet and into space. The magnetic field of Jupiter is 14 times stronger than Earth's and extends millions of kilometers into space. You are at the heart of it. You are inside the thing that generates it. The temperature here is thousands of degrees, not the mild warmth of the middle atmosphere. Thousands of degrees. The specific heat of compression, of material squeezed under enormous weight until the pressure itself generates heat. This heat is what Jupiter radiates out into space. It is what makes Jupiter warmer than it should be, given how little sunlight it receives. You are part of Jupiter's heat budget now. The small amount of energy in you, the warmth of a human body, is being absorbed by the planet. Jupiter is taking your warmth and adding it to its own. This transaction is very much in Jupiter's favor. The pressure is past what any individual system in your body can report. The systems that were reporting it have been overcome, one by one. The pain receptors, which ran out of capacity to report pain. The pressure sensors in your ears, which gave up long ago. The proprioceptive systems that tell you where your body is in space, which became confused and then quiet, in an environment where the usual relationships between weight and position and movement no longer applied. What remains is simple. The dark, the heat, the sense of falling, which has never stopped, which has been the constant fact of Jupiter from the first moment. Jupiter is the oldest planet in the solar system. It formed first. Before Earth, before Mars, before Venus, before Mercury, Jupiter was here. It formed within the first few million years after the solar system began, sweeping up material and growing until it became what it is, the great gravitational presence that shaped everything that came after. Earth exists partly because Jupiter exists. Jupiter's gravity protected the inner solar system from many of the asteroids and comets that would otherwise have continued to impact Earth long after life began. Jupiter caught them instead. It has been catching things for 4.5 billion years. It is catching you now. The falling changes, not stops, changes. At this depth, the material around you is dense enough that falling and floating become the same thing. You are not dropping through empty space anymore. You are suspended in something that has more in common with a very dense fluid than with air. Your weight and the resistance of what surrounds you have reached an equilibrium of sorts. You are still moving downward, but the motion is slow, deliberate. That the unhurried motion of something that has been accepted by the planet rather than falling through it. This is how Jupiter takes things. Not violently, not explosively, with patience, with the specific patience of a planet that has been here for 4.5 billion years and has absorbed everything that has ever entered it, and will continue absorbing things long after the last human being has lived and died and been forgotten. You think about the surface, not Jupiter's surface, which does not exist, your original surface. The planet you came from. The one with the thin blue atmosphere and the liquid water and the specific combination of conditions that allows the chemistry of life to work. You think about what it looks like from space. A blue and white marble, the pictures always say. A pale blue dot from further away. That planet is very far from here. Jupiter and Earth are never closer than about 600 million kilometers. When you were falling through the upper atmosphere in the amber light of Jupiter's cloud bands, Earth was a bright star somewhere above and behind you. Now there is no above and behind. There is only the dark and the heat and the pressure and the slow continuous motion downward. You have been part of Jupiter for a while now. The materials that made you are still here. Nothing is lost. The atoms that were you are now part of the fluid that flows through Jupiter's interior, carried along by the convection currents that have been running for billions of years. The heat that was in you has been absorbed. And the carbon and oxygen and hydrogen and nitrogen that made up your body are mixing with the hydrogen and helium that Jupiter is made of. Jupiter is larger than it was. By a very, very small amount. You have contributed to Jupiter. The great red spot is still spinning above you. 350 years of continuous rotation. When it finally stops, if it ever does, it will be because the atmospheric conditions that sustain it have changed, because the energy feeding it has run out, because Jupiter itself has slowly cooled or shifted. Not because of anything you did or anyone did. The storm spins on its own logic. Everything on Jupiter operates on its own logic. The logic of mass and gravity and heat and pressure and time, measured not in human years but in the deep time of a solar system still in the process of becoming itself. You saw the cloud bands from above. That is worth holding on to. The specific view of Jupiter's upper atmosphere when you were still in the cold. still at the top of the fall, the cream and the amber and the brown, the bands running parallel to the equator as far as you could see in both directions. The storms spinning off the edge of the bands, the great red spot below you, enormous and patient. No human eye has seen that view from inside the atmosphere. Probes have sent back data. Spacecraft have flown through, but no one has fallen into Jupiter and looked around with their own eyes at what the largest planet in the solar system looks like from the inside. You did. You saw the lightning from close up, not the small blue threads of an Earth thunderstorm. The thick branching discharges of Jupiter's electrical activity, lighting up the amber clouds with a flash that made the whole atmosphere briefly pale. You saw the rain, the helium rain falling through the dark, the possibility of diamonds in the deep air. The weather cycle of a planet that has no ocean and no land and no surface to interrupt the patterns of its atmosphere. Just the endless motion of gas and pressure and heat from the center out. You fell through the great red spot. You felt the edges of it, the chaos of the boundary zone, the turbulence of 350 years of continuous rotation, meeting the flow of the jet streams. You were inside the largest storm in the solar system for a time. These things happened. They were real. The dark and the heat and the pressure were also real. Jupiter does not separate the beautiful parts from the other parts. Jupiter is all of it at once. Somewhere above you, right now, the 4 large moons of Jupiter are moving in their orbits. Io with its volcanoes, Europa with its hidden ocean, Ganymede, the largest moon in the solar system, larger than the planet Mercury, Callisto, ancient and cratered, its surface unchanged for billions of years. They are up there, circling the planet that holds them, held by the same gravity that is holding you now. They have been orbiting Jupiter for 4.5 billion years. They will orbit it long after this moment is over. Jupiter keeps what it takes. The heat is very large, not hot the way a fire is hot, not hot the way Venus was hot. The heat here is the heat of compression, of gravity doing to matter what gravity does when there is enough of it. It is the heat of Jupiter, being Jupiter. Massive, ancient, the first planet, the one that was here before the others. You are part of that heat now. The falling has slowed to something that is almost not falling anymore, almost floating. The density of the fluid around you and the density of what you have become are close to the same. You move downward still, but slowly, patiently, the way everything moves in Jupiter's interior, which is the way of something that has all the time in the solar system. You think about the view from the top. The very first moment. The cream and brown bands. The distant light filtering through. The scale of the sky above you. That was Jupiter too. The same planet that is now pressing in from every direction was also the planet of that first view. The same planet. Jupiter is its own full range. From the cold beauty of the upper atmosphere to the crushing dark of the interior. And it is a single continuous thing, a planet that contains within itself everything from frozen ammonia clouds to liquid hydrogen to heat thousands of degrees deep. All of it Jupiter, all of it happening simultaneously. The beautiful part and the terrible part, not separate, but the same thing at different depths. You fell through all of it. You saw the bands and the storm and the lightning and the dark rain. You are part of the heat now, part of the interior, part of Jupiter. Close your eyes. The clouds were cream and brown and amber. The lightning was very bright. The storm has been spinning for 350 years. It is still spinning. You were here. A note of science. Jupiter is the largest planet in the solar system. Its mass is 2.5 times greater than all the other planets combined. More than 1,300 Earths could fit inside it by volume. Jupiter has no solid surface. The planet transitions gradually from gas to increasingly dense fluid as you descend. There is believed to be a solid core at the center, but it is buried beneath tens of thousands of kilometers of extreme pressure and temperature. The exact nature of this core is still debated. Jupiter's atmosphere contains ammonia ice clouds in the upper layers, ammonium hydrosulfide clouds in the middle layers, and possibly water clouds deeper down. The distinctive banded appearance comes from alternating zones of rising and falling air, moving in opposite directions. And the boundaries between bands are sites of turbulence and smaller storms. The Great Red Spot is a storm that has been observed continuously since the 1800s. Though it may have existed for much longer, it is currently about the same width as Earth. In the 19th century, it was wide enough for 3 Earths side by side. The storm is slowly shrinking, and scientists are uncertain whether it will eventually disappear or stabilize. Jupiter's winds reach over 500 kilometers per hour in the jet streams between cloud bands. The Galileo probe, which entered Jupiter's atmosphere in 1995, recorded wind speeds of around 600 kilometers per hour before being destroyed by heat and pressure after 58 minutes and approximately 200 kilometers of descent. So the theory that diamonds may form in the deep atmospheres of Jupiter and Saturn comes from research published in 2013. Under the right conditions of pressure and temperature, carbon from methane molecules could crystallize into diamond. These diamonds would eventually fall to depths where they melt back into liquid carbon. The diamonds, if they exist, would be millimeter to centimeter in size. Jupiter has at least 95 known moons. The 4 largest, discovered by Galileo in 1610, are Io, Europa, Ganymede, and Callisto. Europa is considered one of the most promising places to look for life beyond Earth, because it has a global saltwater ocean beneath its ice shell that contains more liquid water than all of Earth's oceans combined. Jupiter is the oldest planet in the solar system. It formed within the first few million years after the Sun, and its presence shaped the formation of all the other planets. Its gravitational influence continues to affect the solar system today, deflecting many comets and asteroids that would otherwise reach the inner planets. Next, Saturn.